is Flash Isaac, and I'm a teacher from the future. Algebra covers polynomial, variation, inequality, AP and GP, matrices, and determinants, binary operation. These are the algebra topics in JAMB. Now, what is polynomial? Polynomial is simply an expression with coefficients, exponents, a constant. That is basically a polynomial. If I give you something like this, 2s plus 3, you see that this s is a variable. Yes, polynomials, they have variables as well. S is a variable. 2 is the coefficient of the variable. And 3 is a constant. This expression also has a power. This is the same thing as raised to the power of 1. Anytime you see just an s or a y, it is the same thing as raised to the power of 1. This can also be written this way, 2y plus 3, where this is y raised to the power of 1. The variable is y, the power is 1, and the coefficient of the variable is 2, then 3 is constant. We can also do like this. This is a polynomial, 4s squared minus 2s plus 3. This is a variable, this is another variable, this is a constant. These are coefficients of the variable, and this is power or exponent. This is the full expression here is also a polynomial. However, they are of different degrees. This takes us to the degree of polynomials. Degree of polynomials is the highest power to which a polynomial is raised. Now look at here, this expression or this part. You will see that here is 1. The highest power of variable is 1. Polynomials, they have descending power of variables. You see from 3 to 1. Now, picking out only this expression, the highest power of variable is 1. This is therefore a linear polynomial or a linear expression. There is a difference between expression and equation. This here, like 2s plus 3, this is an expression. And what type of expression? Linear expression. How about I do something like this? 2s plus 3 is equals 0. This is an equation. It is an equation not because there is 0 here. It is simply because there is equal to sign. So, when you have values separated with equality sign, it is referred to as equation. While this is a linear expression, this is a linear equation. Now, look at this second expression. You will see that the highest power of variable is 2. Arranging the powers in descending order, you have raised to the power of 2, then you have raised to the power of 1. The highest power is 2. Therefore, this is a quadratic polynomial, and this is an expression. By the time you introduce equality sign, something like 4s squared minus 2s to the power of 1 plus 3, this is referred to as, let's say, equals 0 or equals anything. This is quadratic equation, quadratic expression, quadratic equation, and they are both quadratic polynomial because the highest power of variable is 2. Now, a polynomial where the highest power of variable is 3, like in this case, is a cubic polynomial or a cubic expression. If there is equality sign, it becomes a cubic equation. Now, in mathematics generally, any expression with power raised to the power of 2, 3, 4, 5, and 6, they are all referred to as polynomials. Polynomials. In everyday life, we come across things like A is equals LB, which means area is length times breadth. We can also see something like A is equals pi r squared. We also see equation like F is equals A. Then we see something like v is equals u plus at. Then you see something like s is equals ut plus half at squared. You have so many of these formulas. Formulas are rules that make use of the mathematical symbols. And for every mathematical formula, or for every formula generally, you have the presence of variables and the presence of equal to sign. Now, in every formula, you will see a single variable that every other thing equates to. Look at it. In this case, you see just s here. Every other thing, they are equal to s, which means s is a single variable on the left hand side and it is equal to everything on the right. Here, you see v and it equates to everything here. Therefore, u plus at, everything adds up to give us exactly what v is. F is equals ma. F is a single variable that is equals two other variables. A equals pi r squared. A is a single variable that equals pi r squared. Similarly, A is length times breadth. A is a single variable that equals L and B. All these single variables you are seeing, usually on the left hand side, that every other thing is equal to, are referred to as the subject or subject of formula. So, in this case, A is the subject formula. In this case, A is the subject formula as well. In this case, F is the subject formula. In this case, V is the subject formula. And in this case, S is the subject formula. For calculations, there are cases where we need to change subject formula. If you know that force is mass times acceleration, and I tell you to find acceleration, you need to do everything possible so that acceleration will stand alone and be equal to every other thing. It becomes the subject. If you are doing that, you are doing what we refer to as change of subject formula. Because the original subject formula here is F. If you are changing it to A, you are changing the subject of the formula. If here I say, okay, this is final velocity, this is initial velocity, this is acceleration, and this is time, and I say find initial velocity, we definitely have to bring initial velocity out so that it will be equal to every other thing. So initially, this isn't the subject. Making it the subject meaning you are changing the subject of formula. In JAM mathematics, you'll be given a lot of formulas, a lot of equations, and asked to change the subject formula. How do you do that? To change subject formula, you do everything possible to make sure that the one you are changing to is standing alone, while every other thing goes the other side of the equation. And doing so, you must make sure that it is legal or it is legal, because there are illegal activities, illegal ways people change subject formula. If you don't do it legally, you get a wrong answer. So in mathematics, things are not done anyhow. We do things the right way. And there are rules you must follow to change subject. So far, we've been able to establish that polynomials are expressions with ascending or descending power of variables. And we said that the degree of polynomial is the power of variable, or the highest power of variable. Looking at this polynomial, you see the power are descending. This is raised to the power of 5, 4, 3, 2. This is the same thing as raised to the power of 1. And here is the same thing as raised to the power of 0. S raised to the power of 0 is 1. And 2 times 1 is 2. This is why in constants we don't add the s raised to the power of 0. The highest power here is 5. Therefore, the degree of this polynomial is 5. If we have a polynomial with the highest power of variable 1 only here, that is a linear polynomial. If the highest power of variable is 2, that is quadratic polynomial. If the highest power of variable is 3 from here down, this is cubic polynomial. If it's more than 3, we just say polynomials of degree dash. In this case, polynomials of degree 5. Let us begin with substitution of polynomials. If you might have function of s is equals 3s raised to the power of 4 minus 5s raised to the power of 3 minus 7s raised to the power of 2 minus 4s plus 2. Evaluate function of 3. This is function of s, and we are asked to look for function of 3. By the way, the degree of this polynomial is 4. Anytime you see something like this, function of this is this, find the function of this, it simply means that anywhere you see s, put 3. Because here it's in terms of s. Now they are saying in terms of 3. S is equals 3. So, if s is equals 3, the function of 3 is equals 3. Instead of s is now 3. So you put 3 raised to the power of 4 minus 5. Instead of s is now 3. So 3 raised to the power of 3 plus 7. Instead of s is 3, but the s is raised to the power of 2. So 3 raised to the power of 2. What am I doing? 4, 3 raised to the power of 2 minus 4. Instead of s, it is 3. 3 plus 2. This will simply be 3 times 3 raised to the power of 4 is 81. 3 times 3 times 3 times 3. So this is 81 minus 5 times 3 raised to the power of 3 is 3 times 3 times 3. That is 27. 27 plus 7. 3 raised to the power of 2. That is 9. 3 times 3, 9. 9 minus 4 times 3, 12 plus 2. 3 times 81. 3 times 81 is 243 minus 5 times 7 is 135. 7 times 9 is 63 minus 12 plus 2. 243 minus 135 plus 63 minus 12 plus 2 will give you 161. So the function of 3 is 161. Now look at this other question. It says if the function of s is 4s raised to the power of 3 plus 3s squared plus 2s minus 4, find the function of 2. This is substitution of polynomials. Anywhere we see s, we simply put 2. Therefore, the function of 2 will simply be 4 times 2 raised to the power of 3 plus 3 times 2 raised to the power of 2 plus 2 times 2 minus 4. So we substitute here. 2 raised to the power of 3 is 2 times 2, 4 times 2, 8. We have 4 times 8 plus 2 raised to the power of 2 is 4. So 3 times 4 plus 2 times 2 is 4 minus 4. 4 times 8 is 8 plus 8, 16. Another 8 plus 8, 16. So 16 plus 16. 6 plus 6 is 12. 1 plus 1 is 2. Plus the 1 you carry, 3. So 4 times 8 is 32. You have 32 plus 3 times 4 is 12. Plus 4 minus 4. 32 plus 12. 32, 12. That is 44. Yes. So 44 plus 4, 48. Minus 4, 44. So the function of 2 is equals 44. So anywhere you see question like this, you give him an expression and you ask to look for function of dash. If here were to be 3, if function of t is equals 3t raised to the power of 4 minus 5t, any letter they use it doesn't matter. The letter doesn't matter. It must not be s. So that is how you substitute polynomials. How about addition and subtraction of polynomials? Addition and subtraction of polynomials is something that you already know. And take note of this. If I say s times s, this is equals s squared. If I say s plus s, this is equals 2s, not s squared. If I say s squared times s, this is equals s cubed. If I say s squared plus s, this is equals s squared plus s. You cannot add variables of different degrees. It is not possible. However, you can only multiply them. If I say 2s minus s, this is equals 1s or s. However, if I say s squared minus s, this is equals s squared minus s. You cannot subtract variable of different degrees. Now look at something else. If I say s times y, this is equals s y. If I say s squared times y, this is equals s squared y. However, if I say s plus y, you cannot say this is sy. No. S plus y is equals s plus y. You cannot add different variables. A times b is ab plus, but a plus b remains a plus b. You can't add different variables, and you cannot add or subtract the same variable of different degrees. With this knowledge, you should be good to go when it comes to addition and subtraction of polynomials. Look at the first question before us. It says add 3s squared minus 7s plus 3 and 7s squared plus 4s minus 5. When you are adding or subtracting polynomials, you arrange them according to their degrees. Look at this. Since we are adding, you take this or anyone first. You say 3s squared minus 7s plus 8. You say plus. Then here, they are of the same degrees, so you can arrange them pair to pair, plus 4s minus 5, like this. For number 2, find this guy plus this guy. So we are still dealing with addition. You simply write 5s raised to the power of 4 minus 9s raised to the power of 3 plus 2s squared minus 5s plus 7. Now, they are of different degrees. This is of degree 4 and this is of degree 3. So, while arranging, you put them according to their degrees. We can't start from here because this is of lower degree. We start from raised to the power of 3. So, we come here and see this okay. This addition, it means add. So most time they will give you in this form, add this and this. I'm just using this plus to show addition. It doesn't mean they are the same polynomials. Thank you for understanding. 4s raised to the power of 3, start from here, minus 5s squared plus 4s minus 5. Now, what if you have something like this? If here if it were like this, what would you do? If it were like this, it doesn't mean there is no constant. It only means the constant is 0. So it means you just put 0 here like this. But in this case, it is minus 5. Now look at something. What if you have a question like this? Add 3s squared minus 7s plus 8. Add this and 7s squared minus 5. Something like this. You notice that We have the degree 2, but we don't have s raised to the power of 1, and we have 5. This thing you are seeing is the same thing as 7s squared plus 0s raised to the power of 1 minus 5. Because polynomials must be in descending or ascending power of variable. Since they did not give us s, we'll simply take it as 0s raised to the power of 1. And 0s raised to the power of 1 is what? 0. So if you are adding this, you will do something like this. 3s squared minus 7s plus 8. Then under 7s squared plus 0s minus 5. So you must make sure you fill all those ones. You don't see something like this and write them under here. They are not of the same degrees, or you write them like this. No. You must arrange them according to their degrees. That being said, I will solve one of them. I will solve this. You solve this. It's basically the same addition and subtraction. I'm just giving you these other principles to guide your answer. Now, plus 7 minus 5. Plus 7, you have 7. Minus 5, you are owing 5. If you have 7, you are owing 5. Of course, you will pay. After payment, what happens? You will still have 2 remaining. Because what you have is more than what you are owing. So here, you have plus 2. Up next, we have minus 5s plus 4s. You are owing 5s. Somebody dashed you 4s. So you must pay what you are owing. But even after paying the 4s, you will still be owing. And you'll be owing 1s. That means minus 1s or minus s. So here is minus s. Up next, you have 2s squared. That is plus 2s squared minus 5s squared. They are of the same degree, so addition or subtraction would come to play. 2s squared minus 5s squared. You have 2s squared, you are owing 5s squared. Obviously, after paying, you still be owing 3. So minus 3s squared. Minus 3s squared. Up next, minus 9s raised to the power of 3 plus 4s raised to the power of 3. You are owing 9. You have 4. After paying, you still be owing 5 if I am correct. So minus 5s raised to the power of 3. Now here means 0s raised to the power of 4 plus 5s raised to the power of 3 plus 0s, 5s raised to the power of 4 plus 0s raised to the power of 4, 5s raised to the power of 4 remain. So you can choose to ignore this or add it. That is it. Let's look at the subtraction question. They said we should subtract this from this. This simply means that this one is bigger. What you are subtracting from is bigger than what you are subtracting. So we write the bigger one first. 9s raised to the power of 4 plus 5s raised to the power of 3 plus 7s squared minus 2s plus 5. The truth is, a lot of you are very, very intelligent, extremely intelligent. Your problem is distraction. As you are watching this video now, you see notification, you go and check. You see message, you watch comedy, you laugh, you come back to watching videos. Now, most of those things, gossip, jokes, and the rest, they try to deaden your capacity to think, because you don't require mental capacity. You don't need to think. You don't use your brain to watch all those things. By the time you start coming to think, there is a problem. Some of you, you don't want to offend anyone. You want to study. You really want to pass. But a friend comes, let's go out. You follow. And most of you are in a relationship. All this heartbreak, heart attack, or trying to please your boyfriend, you are studying, he sends you a message, you want to reply, you don't want to offend anybody. All those kind of things, they actually kill you and weigh you down. If you focus, you will pass very, very well. You are intelligent. 99.9% of the relationship you are in now that will affect your job, your academic, your life, your heart, it will not lead to marriage. It's going to break. 99.99%. Mark it. Is the standard. It's not going to lead anywhere. So why let random person kill your dream kill your education. When you can just take away all this distraction, all this friends, focus, pass exam, graduate. You have time to do all that. There is time for everything. Anyway, back to the question. We are subtracting this from this. This is of degree 4 and this is of degree 3. This can be degree 4. This is of degree 3. 3s raised to the power of 3 minus 3s raised to the power of 2 plus 3s minus 2. This is the correct question. So we start writing this from here. 3s raised to the power of 3 minus 3s squared minus 3s minus 2. Here is minus. From here, you have plus 5 minus 2. Take note of signs. Look at this. Here is plus 5. Now, what are you doing? You are subtracting minus. Now, what is here? Minus 2. Minus 2. This leaves us with 2 minus. And that is plus 5 minus 2. Anytime you have 2 minus, it turns to plus. Minus times minus is plus. So 5 minus 2 is the same thing as 5 plus 2. And this is 7. So here we have plus 7. The next thing we have here, look at it. We have minus 2s. The operation is minus. So minus. And what we have at the bottom is another minus. Minus 3s. Please take note of these signs. In fact, they have set more questions from subtraction of polynomial than from addition. Because they know that you will miss this addition. You just see here, you say 5 minus 2 and drop your answer. So it is not done that way. That is illegal. From here, we know that minus is plus. Minus times minus is plus. Plus times minus is minus. In fact, anytime you see plus and minus or minus and minus, so long minus is there, plus and minus, 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 plus, plus. This will give you minus 2s. Minus times minus is plus, plus 3s. So minus 2s, you are owing 2s, plus 3s, you have 3s. After paying, there will be 1s remaining, and that 1s is your own. So this is plus s. Plus s. Next, we have here. And what do we have there? Plus 7s minus. Then we have minus 3s. Minus 3s. So this leaves us with another minus and minus. Minus is plus. Therefore, we have plus 7s plus 3s. 7s plus 3s, that is 10s. So here is plus 10s. Then we have here. So for here, we don't need to bother because we have plus 5s raised to the power of 3 minus 3s raised to the power of 3. This is basically 2s raised to the power of 3. So here you have 9s raised to the power of 4 minus 0s raised to the power of 4. So this will give you 9s raised to the power of 4. So plus. Now, to multiply polynomials, it is the normal multiplication you know. You simply distribute one item over another. You therefore have something like this. 2s, then 3s plus 2. You write the second one plus 1, then you write 3s plus 2. You've distributed one over another. That is multiplication of polynomials. In this case, 2s times 3s, that is 6s squared, plus 2s times 2, that is 4s, plus 1 times 3s, that's plus 3s, plus 1 times 2, 2. This will give you 6s squared, plus 4s plus 3s, plus 7s plus 2. So this is the expanded form of this guy. How about you have something like this? This is of degree 3. And here you have s raised to the power of 2. Here you have s raised to the power of 2 as well. So we therefore need to simplify this part. That becomes s squared minus 2s squared. That is 1s squared, and you are owing 2s squared. That will remain minus s squared. Then here we have in terms of s, here we have in terms of s. So plus 6s minus 5s. That is s plus 1s. Everything you are seeing here boils down to this. They did this to confuse you. So degree 2 s, you simply becomes like this. Which means this is the same thing as saying multiply 7s raised to the power of 3 minus 5s squared plus 4s minus 9 by, what was the answer again? Okay, minus s squared plus s. Multiplying polynomials, you can follow any means. You can do what works for you. There is no big problem in multiplication. But I will recommend you distribute over another. Distribute this smaller one over the larger one to have something like, you bring the first one minus s squared distributed over 7s raised to the power of 3 minus 5s squared plus 4s minus 9. What is the next? Plus s. So you write plus s and distribute it over the same long polynomial over 7s raised to the power of 3 minus 5s squared plus 4s minus 9. Expanding this, you have minus s squared times 7s. This will simply give you minus 1 times 7, 7. S raised to the power of 2 and s raised to the power of 3 is simply, if you have s raised to the power of 2 times s raised to the power of 3, in this it says pick one of the base, add the power 2 plus 3. So this is s raised to the power of 5. Take note of that. It is not s raised to the power of 6. When you are multiplying, you take one base, you add up the powers. Therefore, we have raised to the power of 5 minus s squared times minus 5s squared. That will give you minus times minus plus 5s raised to the power of 4 plus minus s squared times plus 4s. That will be minus 4s raised to the power of 3 minus s squared times minus 9 to have plus 9s squared. If you are able to follow signs properly, you won't have much issues in mathematics. All this not knowing that minus times minus is plus, or forgetting or not minding, will make a big difference. So here is plus s times 7s, that is 7s raised to the power of 4 minus 5s raised to the power of 3 plus 4s squared minus 9s. So food is ready. This takes us back to simplification, and simplification involves basic addition and subtraction. We start with the highest degree. This polynomial is of degree 5. So minus 7s raised to the power of 5. Then for 4, you have degree 4 here, you have degree 4 here. Plus 5s plus 7s. That will give us 12. 7, 8, 9, 10, 11, 12. So plus 12s raised to the power of 4. Then we have degree 3 here and degree 3 here. Minus 4s raised to the power of 3 minus 5s raised to the power of 3. Minus minus. That is, this is not minus times minus. This is minus 4s raised to the power of 3 minus 5s raised to the power of 3. You are owing 4s raised to the power of 3. You borrowed another 5s raised to the power of 3. You'll be owing 9. So minus 9s raised to the power of 3. Then of degree 2, we have here and we have here. So 9s squared plus 4s squared, that will give you 13s squared. So What else? What else? What else? What else? Minus 9. If our solving is correct, then this is your answer. If it is not correct, you can do the correct thing and let me know. My aim is to make sure you understand, not to prove anything to you. This is everything you need to know about division of polynomials. For example, this question says, divide s raised to the power of 3 minus 4s squared plus 2s minus 3 by s plus 2. This is of degree 1, while this is of degree 3. The second one, s raised to the power of 3 plus 3s squared minus 4s minus 12 divided by s squared plus s minus 6. In both cases, we are asked to divide. Division of polynomials requires application of long division. What is long division? You have a box like this. In school, they made long division difficult for us, but in reality, it is not so difficult, especially when you are dealing with Flash Isaac. I try to make everything as simple as it can be. The one with the highest degree should be inside the box. So that should be s raised to the power of 3 minus 4s squared plus 2s minus 3. Dividing by s plus 2, which is the one with the lower degree. That one should be at this side. S plus 3. Now, in polynomials or every long division, we basically have 4 parts. The first part is the dividend. In this case, this one is the dividend, the main one you are using to divide. If I say 80 divided by 2, this is the dividend, and this 2 you are using to divide is the divisor, which means here this is the divisor and here this is the divisor. The dividend of the polynomial is usually inside the big box and the divisor is here. In the process of long division, which I will show you, you will get some values at the top of this division box. The values we have at this top is referred to as quotient, and your result, or the result of polynomial division, or the result of long division, is the remainder. Which means if your remainder is 0, it means that the divisor is a factor of the polynomial. This is an introduction or the basis which forms the factor and remainder theorem. If I divide a polynomial by a value and I get 0, it means that that divisor or that value is a factor of the polynomial. Now, divisor, quotient, dividend, and remainder. The relationship between divisor, quotient, dividend, and remainder is that the dividend or the polynomial is equals quotient times divisor plus remainder. If JAMB decides to give you quotient, they will tell you that after polynomial division, we got the quotient to be this, and the divisor was this, and the remainder equals this. Find the polynomial or find the dividend. To find the polynomial, you simply say the quotient times the divisor, your answer plus the remainder. In this case, the quotient is 3s minus 4 and the divisor is 2s plus 6. If you multiply them via what I taught you earlier under multiplication of polynomials, that should be something like this: 2s plus 6 and 3s minus 4. I told you to distribute one over another, which is you pick 1, 2s, distribute it over the second box. What is remaining? Plus 6. You write out plus 6, distribute it over the same box. From here, 2s times 3s, this should be 6s squared minus 2s times minus 4 minus 4 times 2, 8, 8s plus 6 times 3, that should be 18 plus 18s minus 6 times 4, that should give you 24, minus 8s plus 18s, that is plus 10s minus 24. This is simply quotient times divisor plus remainder. Remainder here is 0 plus 0. This will give you 6s squared plus 10s minus 24. What does that mean? The polynomial or dividend is quotient times divisor plus remainder. All this being said, step 1, make sure the polynomials are in order, which means either ascending or descending power of variables. In this case, 3, 2, 1, s raised to the power of 0. In this case, s raised to the power of 1, s raised to the power of 0. It is in order. A situation where you have minus 4s squared plus s raised to the power of 3 plus 2s minus 3. Here, the degree of the polynomial is not 2. It is not by the first one. It is by the highest power. The degree here is 3. So, it is your duty to make sure that you rearrange to get the descending power of variable. After that, step 2 in long division is put the term with the highest power inside the box, which we've done, and the one with the lower power outside the box, which we've done. Step 3, divide the variables with the highest power and put the result on top of the box. That is how we get the quotient. The variable with the highest power here is 3, and the one with the highest power here is 1. That is s raised to the power of 1. So the first one here, you divide them. The one with the highest power will obviously be at the top. The one with the lower power will obviously be at the bottom. S raised to the power of 3 divided by s raised to the power of 1, that will give you s squared. In this it says, once the bases are the same and you are dividing, subtract the power. This is s raised to the power of 3 minus 1. We are subtracting the power since we are dividing. Indices, logarithm, and surds are so important throughout your mathematics journey. So, step 1 or step 3, we divided the variables with the highest power and we got our answer at the top. 4, use the answer obtained to multiply the divisor. This is the divisor. We picked the first one here and the first one here, we divided, and this is our result. Use this one to multiply the divisor and put your answer below the dividend or below the polynomial. How do you do that? S squared times s raised to the power of 1, here will be s raised to the power of 3. S squared times plus 2, that will give you plus 2s squared. This is what we have. Every other thing here, there are 0s and blah 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 blah. Step 5, subtract the result from the dividend or subtract the result from the polynomial. You simply do like this, like this. We are back to trenches, subtraction of polynomials, which we did earlier. So you put minus here. Ladies and gentlemen, nothing here, nothing here. So minus 3 remains, plus 2s remains, something here, something here. Remember, we are subtracting. Please take note of the sign when subtracting. I am begging you in the name of God. So here, this is minus 4s squared, and this is already minus, then plus 2s squared. Plus and minus will always win. So this is the same thing as minus 4s squared minus 2s squared. You are owing 4, you borrowed another 2. That should be minus 6s squared. Minus 6s squared. To subtract or add polynomials, they must be of the same degrees. You don't say 2s squared minus or plus s to the power of 3. No. The powers must be the same for you to add or for you to subtract. It is only multiplication that disobeys this law. For multiplication, whether they are of the same degree, different letters, you can multiply. Alright, then here is s raised to the power of 3 minus s raised to the power of 3. This is 0. So this one is gone. This is what we are left with. Continue until you arrive at a degree lesser than the divisor. The divisor here is of degree 1. After this first round, our result is of degree 2. We need to continue the same step until the degree of this guy is lesser than the one of the divisor. So, what is the problem with continuing the step you followed before? There shouldn't be any problem. at all. In fact, there should not be problem in the first place. The step is, this is now our new polynomial. In this our new polynomial, we pick this highest power here, and we pick this one remains the highest power. We divide the highest here by the highest here to have minus 6s squared over s raised to the power of 1. Ladies and gentlemen, this will give you minus 6s. So minus 6s comes to meet s squared to have minus 6s here. After the division and you have the quotient, we simply use the quotient again to multiply the divisor, and that is minus 6s times s will give you minus 6s squared. Minus 6s times plus 2, that will give you minus 12s minus 12s. So again, we subtract minus. Here is minus 3, nothing here to support it. Minus 3 remains. Here, s and s, there is something. 2s minus 12s minus 12s. This leaves us with minus minus. Minus times minus is plus. This is 2s plus 12s. 2s plus 12s, 14s. So this is 14s. Then here, minus 6s squared, minus is here. There is another minus, minus 6s squared. This will give you minus 6s squared plus 6s squared, which is 0. So we are here now. Our new polynomial is 14s minus 3, or our new dividend. But the divisor is s plus 2. This one is s raised to the power of 1. This one is s raised to the power of 1. We will not stop until the power here, or the variable here, is of lower degree than the one here, which means we proceed. This is now our new dividend, or our new polynomial. The step remains the same. It is just long, but the same thing. You are just playing with life. Here, 14s, here is s. 14s divided by s, this will give you 14. Most times, or all the time, once you have a constant in the divisor, it shows that that is your last step. Since we have gotten a constant here, 14 plus 14 precisely, it is here. So this will be our last step now. This is the new quotient. So we use 14 to multiply the divisor again. 14 times s is 14s. 14 times 2, that is 28. So plus 28. Then we draw this like this. We subtract again. Minus 28 plus 28. That should give us 20 plus 25 if I am right. So plus 25. 14. No, I am not right. This is minus 3, and there is minus here. Minus plus 28. This is minus 3 minus 28. That should give you minus 31. Minus 31. 14 minus 14 is 0. So we've gotten an answer of lower degree than this. That is it. Here is our remainder. Here is the quotient. Here is the dividend, or you can simply say the polynomial, and here is the divisor. Let me take you through the second question so you get used to long division. Here you will have something like this: s squared plus s minus 6. Then here s raised to the power of 3 plus 3s squared minus 4s minus 12. This is it. What do we do? We pick the first one here, and we pick the first one here. S raised to the power of 3 divided by s raised to the power of 2, that is s raised to the power of 1. Or we simply say s. We have one quotient. We use the quotient to multiply the divisor to have s times s squared, s raised to the power of 3 plus s squared minus 6s. We rule, we subtract. No constant here, so minus 12 remains. Minus 4s minus 6s. That is minus 4s plus 6s. That will give you plus 2s. 3s squared minus s squared. That is 2s squared. S raised to the power of 3 minus s raised to the power of 3 is 0. So we are done with step 1. The power here is 2. The power here is 2, which means we have to go another round. Besides, there is no constant here yet. So we pick the first one here and we pick the first one here again to have 2s squared divided by s squared. And this is equals 2 plus 2. So the good thing about this is the polynomial looks longer, the divisor looks longer, but we're already at the last stage. We've gotten constant, baby girl. So life is good. We use the constant plus 2 now to multiply everything here. 2 times 2s squared, 2 times s squared, this is 2s squared. 2 times plus s plus 2s. 2 times minus 6 or minus 12, if I am correct. So we subtract. Minus 12 minus 12. That is minus 12 plus 12. That will be 0. 2s minus 2s, 0. 2s squared minus 2s squared, 0. Baby girl, everything here is 0. Now, the remainder is 0. In other words, there is no remainder. What does it mean when the remainder is 0? If remainder is 0, it means that the divisor is a factor of the polynomial. The factor and remainder theorem is a very interesting concept in polynomials. Ladies and gentlemen, every time you are given questions like this, they say find the remainder when s squared minus 5s plus 4 is divided by s minus 1. You do not need to use long division. No. Since this is the dividend of the polynomial and this is the divisor, the first thing you will do is equate the divisor to 0. S minus 1 is the divisor. Equate it to 0. If this is equals 0, it means that s is equals 0 plus 1. It means that s is equals 1. This is your value of s. Substitute it into this polynomial. Therefore, the function of 1 is equals, instead of s, you have 1 squared. 1 squared minus 5 times 1 plus 4. We are substituting. This will give you 1 minus 5 plus 4. And that will give you 0. So the remainder, when s squared minus 5s plus 4 is divided by s minus 1 is 0. That implies that this is a factor of this polynomial. If you divide a polynomial by a divisor and the remainder is 0, it means that the divisor is a factor of the polynomial. That is the basic concept. Similarly, if you are taught to find the remainder when this guy is divided by this, you equate the divisor to 0. So s minus 4 is equals 0. It means s is equals 4. Substitute 4 for all the values of s here. Your answer will be the remainder. If it is not 0, it means that this is not a factor of the polynomial. But that is not your problem. Once you substitute, anything you get, that is the remainder. Interesting, right? Yes. And this is the type of questions you get most times in JAMB when it comes to polynomials. Another thing you will be asked under polynomials is to factorize. If I give you something like this and I say factorize, this means the function of s, there are s's here, is 2s raised to the power of 3 plus s squared minus 13s plus 6. What you simply do is start from 1, make s 1 and see what you will get. If you put function of 1, anywhere you see s you put 1. If you don't get 0, it means 1 is not a factor. Try 2. If you try 2 and you get 0, it means 2 is a factor. You put 2 anywhere there is s here, you will get 0. So s equals 2 is a factor. If s is equals 2 is a factor, it means s minus 2 equals 0. So s minus 2 is a factor. This is your first factor. If you've gotten your first factor, to get this is of degree 3, it will have 3 factors. To get the other 2 factors, you simply do long division. This will be your dividend and this will be your divisor. The quotient here is your other 2 factors. Factorize them, you will get the factors. That will be your assignment. This here, do long division. Your quotient here, factorize it, you will get 2 different values for s, plus this one. These are your 3 factors. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.